Hey guys, what's up? Welcome to the coding practical classes where we're gonna be making a game using Python. So basically, I've split this into 5 parts. The game, it's called Towers of Noise. You can see right here. If you don't know what it is, we'll get into that later. But for now, this just I'll walk you through the parts. So we have the node part, we have the stacks part. It may seem all of this may seem a bit confusing, but we'll clear it out later. So then we have the game part, then we have setting the game up part, and we have the playing the game part. So that's all. After that, what I was mentioning earlier was that we're going to be discussing nodes in today's class. So let's get right into that. So nodes. Nodes are basically the fundamental building blocks of many computer science data structures. They can form the basis for things like linked lists, stacks, as we're going to study later, queues, trees, and all that stuff. An individual node is on your screen right now. You can see contains data and links to other nodes. Like this one contains 5, the integer 5 is the data, and a link to node B, which could be, it's just randomly there. So, yeah, now that you understand a node is just a data structure that contains data and a link to another node. So node A is linked to node B and contains the data, which is the integer 5. Next, you can see on your screen that the data contained within a node can be a variety of types. It could be null, it could be a string, it could be an integer as well. It could also be a list. It's not here, but it could be a list as well. So that depends on the language you're using or whatever, right? The link or links within the node are sometimes like these things are also referred as pointers, but yeah, it's just to get it out there for future endeavors. So typically data structures implement nodes with one or more links. If these links are null, that means you've reached the end of the node, which you've reached the end of the path you were previously following, that path being the node. So a variety of node implementations are depicted in the diagram. You can pause the video and examine the types of data and how some of the nodes are linked. So we move right forward. So often due to the, I'm going to play this video later. Let me explain what the video is going to be having. So often due to the data structure, nodes may only be linked to from a single other node. This makes it very important to consider how you implement modifying or removing nodes from a data structure. You can't just remove node B in this case. All right, it contains important information, which is the data and the link to that. So if you're losing node B, you're losing you're losing node C, and if this is a bigger path, you're going to lose everything down that path. Like node C could be linked to another node, but in this case it's just null, but you're going to lose node C and node B both once you're trying to delete node B. So if you inadvertently remove the single link to a node, that node's data and any linked nodes could be lost to your application. When this happens to a node, it's called an orphan node. So or like, you understand, right? Examine the nodes in the diagram. Node C is only linked by node B. Alright? If you would like to remove node B but not node C, you can't simply delete the link from node A to node B. The most straightforward method to preserve node C would be to change the link to point to node C instead of node B. Alright? However, some data structures, they could handle this in a different manner, but since we're focusing on nodes, so you can see this. You could, if you need to preserve node C. So you could just link that to node C and leave node B as it is, because it's not going to be in your path anymore. It's just going to be node A, node C, etc. But you're not going to lose node C, because node B is linked to node C. If you delete node B completely, you will be losing node C and like everything down that path. So the best way to what would you say, the best uh, best solution, or I can't get the word right here. The best alternative would be to just link node A to node C directly, and node B would be orphaned that way too. Right? Moving on. Let's just review everything we've done. So nodes contain data, which can be a variety of data types. Remember? Contain links to other nodes. If a node has no links, like right here, they are they are null. You have reached the end of your path you're following. Like you went here, here, and this is the end. Nodes can be orphaned if there are no existing links to them. So if there are no existing links, like once I've attached no, once I've made node A's link to node C, node B has no existing links. They have nothing linked to them. Something is linked from them, but there's nothing linked to them, so they're orphaned. They could have been orphaned if they would have been completely deleted, but you would lose node C in that way. So we're preserving node C, yet we're orphaning node B. All right, that's it for the conceptual part of nodes. We have to get down to our Python part for the nodes now. So we'll jump right into that. So if I'll just copy my code, if I'll just copy my code right here and show it to you in a separate tab, that would be wonderful, wouldn't it? All right, we can go in this one and hope there's nothing important in this one. It says practice, so there shouldn't be. All right, this doesn't make sense. You're connected, right? Yeah. All right, this is awkward. All right. Oh, I reloaded it. Just give me a second, guys. I'm using Replit in case you guys are wondering. It's an online code editor or whatever you'd like to call. It doesn't seem to be the best one, but trust me, it's pretty good. So just gonna copy this here, and I'll explain how I've implemented nodes into Python, with Python or into Python or whatever. So you're gonna be using the class, like the class's data type or the data structure, whatever you'd say. Like how we define functions, right? Like def next node, that would be a function. You know how to do that. So exactly like that, this is how you define a class. If you don't know what classes are, you can quickly search up YouTube and check what it is, but I'm not going to go into the basics of Python here. I'm just going to move on. So basically create a class, and then in that class you have the constructor. All right, you can basically when you define a function in a object, it's called a method, the class node being the object here. So this is the method, so this is the constructor. This method is the constructor of this class, right? So what do we have in the constructor? We have the value and the link to the next node. So value could be anything, next node gives it a link. So basically we have two getters over here. What the getters will do is they will get that information. If you want to get the information stored in this node, you'll just get the value from here by typing get value, and you'll probably be having the value for this. And then to get the next node, these are just the getter functions which will access you all the information inside the node, these two things. And obviously nodes, you can't modify the data, but what you can modify is the link to the next node. So remember when we studied where we were basically, if I get right there, where we were basically changing the link from node B, from node A to node B to node A to node C. So we can change the links, but the data is immutable. You can't change the data contained within the node. All right, you can't change the link. So basically that leaves us with two getters and a single modifying method. All right, I hope that's clear. So this was all for today's session, or you would say Coding Practical 1 session. And I think we're pretty much done with the node section of the practical. So I think in the next class, we will be discussing what we'll be discussing. In the next class, we'll be discussing the stacks, obviously. So yeah, that's all.